Okay, so today we're going to start our first online lesson. Again, I'm going to keep it short just because I want you guys to get the feel for it. But keep in mind that moving forward, these lessons will usually be a little bit longer. So these are from the notes that you received in class on Tuesday, so you can get those out. And we're going to do some Math 10 review. Now, if you didn't take Math 10, but you took Math 6, 7 foundations level, you'll be fine because you did this kind of thing then too. So we're going to start with domain and range. We're going to do some notation, continuous and discrete data, and graphing linear relations. And we're not doing all of that today. That's just what's included in this review section. So starting with domain, range, and inequalities. So when we're talking about inequalities, we're talking about linear relations. All these things means that we are now in graphs. Okay, so we're going to be working with graphs for a bit. So we have to remember some of our math words. The first being that domain. And on this graph, remember on every single graph, we can always label our axes X and Y. Okay, and that's what domain and range refer to. So domain is all the possible X values for a linear relation. Okay, so anywhere that line you can trace back down to the x-axis, that's its domain. And that means that the range is all the possible y values for a linear relation. So let's look at this graph here, okay, where we have this little line here. And just a warning, when I draw on the smartboard, it's hard to be exactly precise. So sometimes my graphs will not be as precise as you can make your graphs. Always just try to make your graphs as precise and neat as possible. Sometimes mine will look a little messy, but for sure do yours as neat as you can. So when we look at this graph, we can fill in the terminal point and the origin point. And so if we look at it, remember we were talking about how to write coordinates when we were doing the review last class. So before I write them down, you can pause the video, try to write the coordinates for the beginning and the end point of this graph. So I'm going to just start at the end because it's higher up. This is point 4, 4. Remember that every coordinate should be written in the x, y general formula. Okay, and then the coordinate down at the bottom is 0, 0. It's at the origin point. And I know that my orange line looks off, but we'll go off the black line on your graph. So the graph goes from y equals 0 to y equals 4. And that's for the y values. So that would be our domain or our range. It would be our range because it's the y values. So possible y values are 0, 4, and all points in between. So if I asked you what are points that this line touches on the y-axis, you can go anywhere along here and go across to the y-axis and be able to say what the values are. And so we normally start with the highest and the lowest, so the parameters, or the range is really where that word comes from, and then we try to fill in. So likewise for the domain, the graph goes from x equals 0 to x equals 4. Okay, and then the possible values, because this graph happens just go from 0 to 4 and both x and y are the exact same. Possible x values are 0, 4, and all points between. Now, it's only all points between because this is a straight line. Okay, it's continuous data, and we're going to talk about that again, but in case you're unsure, go look at the review. Remember where we just determined if things were continuous or discrete. So, takeaway message here, domain is all possible x values for a linear relation, and range is all possible y values. So this line here is distinct. It goes from 0 to 4, that's it, and then it stops. Sometimes there are no limits, and in math we say there are no restrictions on a graph. And you can tell that because you can tell that when a line has arrows on either end. Now these arrows are difficult to see, but they are there. That arrow implies that this graph will keep going, or the line will keep going, even though the graph is just showing a snapshot. Okay, so this line is not stopping at what point is that, 6, 4? That's just the last point we can see on the graph. Because it has an arrow, it tells us there is no upper limit. So the graph will continue in the positive. So I write positive with a plus sign with a VE. The positive direction for x and y. Okay, so it will keep increasing in the x direction and the y direction. Just like down at the bottom, there is no lower limit. And this isn't going to always be the case. Sometimes you can have a graph with no upper limit but a lower limit, or vice versa. Okay, so every graph is sort of a new page, and every graph has to be looked at for itself. And again, the graph continues in the negative direction for x and y. So domain and range will continue in the positive and negative direction. Okay, so before we go any further, because we're going to start writing out notation, which is a fancy way to say like officially writing math, we have to talk about inequalities. An inequality is a statement that describes the value of an object or a variable. And an inequality statement will use one of these 4 signs. Okay, so these 4 signs. And I'm sure you've seen these before, and they mean the exact same thing. So when you first see these in like grade 3 or 4, I think, the meaning never changes. So you have this guy here, okay, and this means, and feel free to pause it and try to fill this out and then start it and see if you're correct. This one means greater than or equal to. And that's because it's got the line underneath it, okay? That's what the or equal to means. It's sort of like the equal sign, right? That's why you're putting that little line underneath. The sign going in the opposite direction means less than or equal to, and it's very important that if it has that line underneath, you include the or equal to. Okay, this is going to be the unit where we do the most writing in math. I don't want that to make you nervous because it's a very formulaic kind of writing. Okay, so it's very much the same each time, you just switch numbers. But it's important to learn the terminology because it really helps you. And this is the area of math where we use a lot of symbols instead of writing a long sentence. So it's important to understand these symbols and be able to use them. And then we have This guy without the line, which is just greater than, just greater than, or just less than. Okay, so hopefully these are all familiar to you. Even if they're not, I don't think, overly challenging to remember. But make sure that you're comfortable with them and that you know when to say or equal to, or here where you don't say it. Okay. So for an example, x with this little guy, I'm not going to say it out loud. What would that mean? This means, if we say it out in words, x is greater than 4. Okay? And so you can see why we use this kind of terminology, because it's a million times easier to write this than a sentence, x is greater than 4. So it starts to make sense why we have all this symbol and all these symbols and all the terminology, but it can just be a bit of a learning curve to use. And at the same time, 4 is less than x is the same thing. Okay? Typically, you'll see it written like this. Typically, we will put the variable first, but they are the same thing. Okay? Then here we have, try saying this one, y is less than or equal to -1. So important that you include this part, or equal to. So then how could we write this one, putting -1 first? If y is less than or equal to -1, that means that -1 is greater than or equal to y. Okay, and again, I encourage you, once you watch through this once with me speaking, go through the notes again, see if you can say it to yourself again, and then you can come back and watch the video once more, maybe in a couple days, and just make sure that all these things are cemented. And then we have this guy. Okay, so now we have two inequalities. So we have basically two statements in one. So this means that x is greater than or equal to -5, and x is less than or equal, less than or equal to 9. Okay? And the reason why we put it together, we could also say x is greater than or equal to -5, and x is less than or equal to 9. It's the same thing to put those two statements. This, again, like I said before, mathematicians want to write as little as possible, okay? And a lot of times when you're like a professional mathematician, if that's what they're called, when they write equations, their equations are pages and pages and pages. So they just try to make it as easy as possible. Okay, so these ones, again, come back and practice this one. If those ones with the variable in the middle make you kind of nervous, then you can speak with me about that. And I'll also see if there are some examples in the textbook. Or you could always just Google writing inequalities, and a whole bunch will pop up. Okay, so let's just do a little bit more. And we'll start with inclusive and non-inclusive points on a graph. And in this case, it means just what the English means, okay? Inclusive means to include. Non-inclusive means not to include, okay? Just like a vacation to Mexico or wherever they have inclusive vacations, okay? So if you see a plotted point that is solid, Okay, so that's a solid dot. This means the point is included. Included. Okay, so if I put a solid dot here, and that's at 0.55, that means that wherever I draw my line, that point is included. So 5, is included in the line. If I plot a point with a hollow dot, it means that it is not included. And to break that down further, that means that this is not a possible value for x or y. Okay, so it might be part of the graph, or the line. There we go, I'll put one at 1, 1. I'll connect. Again, your graph will be much more accurate and neater than mine. So there's my other point at 1, 1. Okay? But in this line, the 0.55 is included as a possible value for x or y. The 0.11 is not included. So you cannot have, in this case, x cannot equal 1 and y cannot equal 1. Okay? So that's what we mean. So it's important that we see what kind of dot it is. Okay? And then inequality-wise, this will also come up. And again, we're going to go over everything over and over again. So the reason why we need to be able to know if a dot is inclusive or non-inclusive is that we need to know that information so that we can do our notation. Okay? We're going to start with number lines, and just so we get used to seeing what there is, and then we'll move on to graphs. So when you're using a number line can only show the domain or the range. Okay? So you can have a number line for the domain, and you can have a number line for the range, but you need one for each. So when you work with a graph and you can have your line, that shows your x and your y. But a number line will only show your x or your y. Okay, so let's do this will be a domain, so it will be x. I'm going to put a line here. So my domain would be x is, and since it's a solid line, that means it's going to encompass every single number it passes. And so we say that that is all real numbers. Okay, so all real numbers. But I need to give that a parameter. I need to give that a restriction. It's all real numbers, but where does this line start? And where it starts is that point included. So it starts with a solid dot, which means that 3 is included or not included. Hopefully you all said included. So 3 is included. So inequality-wise, which side are we going to use? Left or right? Right. We're going to use left, okay? So, sorry, that right was a correct, not a, anyway. So we're going to use the left side. So then we have to say, is this going to be all real numbers greater than or equal to 3 or less than or equal to 3? And we can see that all these numbers are getting bigger as we move up the line. So it'll be all real numbers greater than or equal to 3. Okay, so the greater than or equal to is because there was a solid dot. Okay, so that solid dot means that now we say greater than or equal to. So let's do a range one. And I'm going to draw a line here. Okay, and again, remember the arrow on the other end implies it's going to keep going. So I want you to pause the video and try to write this one by yourself. Okay, and again, you can start with y is all real numbers. So look at the dot, look at where the graph starts, the line starts, and where the line starts is at 9, so we can say, and it goes down to the left, so they get smaller, less than 9. Not less than or equal to, just less than, because we have a hollow dot. And then the last one, so we have a solid dot at 7, a hollow dot at -4. This is going to be a domain. Okay, so now we have an inclusive region, okay, meaning that we have a restriction on our line. So we can start with, again, x is all real numbers. Okay. All real numbers what? Let's look at the lower end, -4. So are these numbers greater than or less than -4? They are greater than. Do I include an or equal to? I do not, because I am going to, just one second, you guys are at the door even though you're not supposed to. Okay, sorry about that. So hopefully you said that it should not be or equal to, so greater than -4, because it's a hollow dot. Now we also have to include the upper restriction, so it's greater than 4 and less than. Now in this case, am I including or equal to? Hopefully you said yes, because I have a solid dot there, less than or equal to 7. Okay, so that's where we're going to end today. There is no homework for next class. I do really encourage all of you to get on here as early as possible. And if this at all seems difficult to you, try to watch it more than once. I know that that's not always possible, but at least try to review it before you come to class on Tuesday. So if you have any questions, we can get to those right away. And of course, email me if you have any problems, and have a great weekend.